In this video, I am going to show you a formal proof of the hypotenuse leg theorem, or the HL theorem. This theorem states, if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. We always begin with what is given. So we're going to write that triangle ABC and triangle DEF are given, and angle C and angle F are right angles, making those right triangles. And AB is congruent to DE, so we have the hypotenuse is congruent, and we have BC is congruent to EF, which is a leg of each of those right triangles. And once again, those are givens. The next thing to do is to use the ruler postulate to create a congruent segment. This is also referred to as something that is constructible. We'll extend the line DF and show the point G such that FG is something congruent to AC. The next thing that we're going to say is that angle EFG is a right angle. And the reason why we can say that is that DF and EF are perpendicular. Now, triangle ABC is congruent to triangle GEF. And the reason why, if you look carefully, I have right angles. I have FG is congruent to AC, and I have EF is congruent to BC. So by side angle side, we have congruent triangles. Next, we are going to say segment EG is congruent to segment BA. And the reason why we can say that is CP, CTC. Or 6 parts are congruent to 6 parts. So there's the part AB that's congruent to part GE. Now looking at triangle DEG, you see that it's an isosceles triangle because side DE is congruent to side EG. And the isosceles triangle theorem says that the base angles are congruent, so I can say that angle D is congruent to angle G. And our reason is isosceles triangle. The next statement I'm going to make is statement 7, which says the measure of angle A is equal to the measure of angle G, and the measure of angle G is equal to the measure of angle D. And we can say that because that is the definition of congruent angles. So that takes us being able to say measure of angle A is equal to measure of angle D, because they are amounts that are equal to the same angle, angle G. And that's called the transitive property of equality. So the next thing that we can say here now is that angle A is congruent to angle D. That's the definition of congruent angles. So I'm going to go ahead and mark that angle A is congruent to angle D. And next we're going to say that triangle ABC is congruent to triangle DEF. And if you look carefully, we have right angles that are congruent to each other. We have angle A is congruent to angle D, and we have side AB is congruent to side DE, which was given to us. And that tells us that those two triangles are congruent by angle, angle, side. And so we finish off by saying we have proven it, QED, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent.